Good evening, everybody. Today we will talk about how to find the main trigonometric ratios for the acute angle in the right-angled triangle. Before we start, you should remember with me that the measuring unit of the angle is called a degree, and its symbol is like this. As you see, like a small circle above the number, and each 1 degree has inside it 60 minutes, or we can divide it into simple or small parts like to be 60 minutes, and 1 minute is equals to 60 seconds. So the symbol of degree is a small circle above the number, and the symbol of the minute is a dash above the number, and the second is double dash above the number. Also, before we start, you need to remember with me very important remarks. The first one is the sum of two complementary angles equals 90 degree. So when I'm asking you 30 degree complements what? The word complements means what is the number added to 30 degree to get it 90. I think 30 complements 60 degree. Also, the second one to remember is the supplementary angles. What is the meaning of the supplementary angles? The supplementary angles are two or more angles, their sum equals to 180 degrees. And the last point is the sum of interior angles of any triangle is 180 degrees. Now, let's move to the next step. What are the main trigonometrical ratios of the acute angle? The trigonometric ratios of the acute angle is the ratio between two sides of the right angle triangle. We have three new words. The first one is called sine angle, sine. And the second one is called cosine. The third one is called tangent. Sine, which is written like this, sine, S-I-N, and cosine, which is written like C-O-S, and the last one is tangent and is written T-A-N. How to find the sine and cosine and tan of an acute angle. The sine is the ratio between the opposite side to the angle over the hypotenuse. For example, if I have a right angle triangle like this, A, B, C. For example, I'm talking about the angle A. For sure that AC is a side which is opposite to the right angle, so it's called the hypotenuse. What about the angle A? BC is the opposite of angle A, and AB is called its adjacent. So to find sine A, to find sine the angle A, it will be opposite, which is BC, over hypotenuse, which is AC. To find cosine the angle A, it will be adjacent, which is AB, over hypotenuse, which is AC. The last one is to find the tan of the angle A, it will be the opposite over adjacent, means BC over AB. Okay, let's move to the next part. In the previous slide, we were talking about how to find sine and cosine and tan for angle A. The most important point is determining the angle you are working on. After that, name the sides. For example, I'm working here for the angle A. For sure that the side which is opposite to the right angle is called the hypotenuse. So AC is the hypotenuse of the right angle triangle ABC. For the angle A, BC is the opposite of the angle and AB is called the adjacent. So to find sine A, sine is opposite over hypotenuse, so it's BC over AC. To find cosine angle A, it's adjacent over hypotenuse, which is AB over AC. The last one is to find tan A, which is opposite over adjacent, so it's BC over AB. The next one is to finding the main trigonometric ratios for another angle, which is angle C. For angle C, for sure the AC is called the hypotenuse because it's opposite to the right angle, and very important note to take care of it, that The hypotenuse is the longest side in the right angle triangle. So for sure that the opposite and the adjacent for any angle should be smaller than the hypotenuse, because the hypotenuse is the longest side in the right angle triangle. So to find sine C or cosine C or tan C, we will stop at the angle C, then we will say that AB is opposite to angle C, then it's called the opposite, and BC is called its adjacent. So sine C is opposite, which is AB, over hypotenuse, which is AC. Cosine angle C, BC over AC, or adjacent over hypotenuse. The last one is tan C, which is opposite over adjacent, then it will be AB over BC. Let's solve an example to make sure that we got it. In the opposite figure, he's telling me that ABC is a right angle triangle at A. So before I start anything, ABC is a right angle triangle at A, then BC is called the hypotenuse, because as we studied before that the hypotenuse is the side which is opposite to the right angle, where AB equals 9 centimeter and AC equals 12 centimeter. The first step after getting the figure is to find the missing side. How to find the missing side? I will use the Pythagoras theorem. How? I will say that BC equals square root AC squared plus AB squared, which is equals square root 12 to the power of 2 plus 9 to the power of 2, which is 15. Here he is asking me about sine B, cosine B, tan B, and sine C, cosine C, tan C. I will work for B in the black pen, so it will be this is the opposite, and here it's the adjacent. So sine B, which is opposite over adjacent, means opposite over hypotenuse, means AC over BC, which is 12 over 15, and I will write it in its simplest form, 4 over 5. What about cosine B? Cosine B will be adjacent over hypotenuse, which is AB over LBC, which is 9 over 15, and it will be in the simplest form, 3 over 5. The last one is to get tan B, which is opposite AC over adjacent, which is AB, so it will be 12 over 9, and in its simplest form it will be 4 over 3. The next step, I will move to find sine and cosine and tan of the angle C. I will work on angle C with the red pen, so take care that for C, AB is not the adjacent, it will be the opposite, and BC will not, and AC will not be the opposite, it will be adjacent, like switching, because I changed the position of the angle so that it's very clear that the opposite and the adjacent will change. But take care, the hypotenuse is always called the hypotenuse, because the hypotenuse is usually the side opposite to the right angle. So I will find sine C, cosine C, tan C. Okay, let's do it together. Sine C, it will be opposite over hypotenuse, so it will be 9 over 15, and in its simplest form it will be 3 over 5. What about cosine C? It will be adjacent over hypotenuse, which is 12 over 15, which means 4 over 5. What about tan C? Tan C is opposite over adjacent, so it's 9 over 12, which is 3 over 4. I got the first point. Let's do it and find the second one. To find the second one, I will replace. I got everything. He wants me to find sine B multiplied by cosine C. Okay, I will write it like this: sine P times cosine C plus cosine P multiplied by sine C. Sine B is 3 over 5. And cosine C is 4. I'm sorry, sine B. I'm sorry, I wrote it by mistake. Sine B is 4 over 5, not 3 over 5. I'm sorry for this mistake. So sine B will be 4 over 5 multiplied by cosine C, which is also 4 over 5, plus cosine B, which is 3 over 5 multiplied by sine C, which is 3 over 5. To find the answer, it will be 16 over 25 plus 9 over 25, which is 25 over 25, which is equals to 1, and this is the required to prove. Let's move for a second example. But before we move to another example, I should remember with you what is the Pythagoras theorem. The Pythagoras theorem is in the right angle triangle to find the missing side. To find AC, which is the hypotenuse, the longest side, I will do the operation AC squared equals AB squared plus BC squared. Sometimes you would like to write it like this: AC squared equal AB squared, AC equals square root AB squared plus BC squared. You can use it or use this one, whatever you want. The other point is to find AB squared. AB is not the hypotenuse, so I can't put adding sign. It will be subtracting sign. Also, you can find that AB equals square root AC squared minus BC squared. The last one is to find BC. So if I would like to find BC, I will write AC squared minus BA squared or AB squared, whatever you would like to write. So take care that on doing this rule to find the missing side, the only one to take adding sign is the hypotenuse, which is opposite to the 90 degree, and it's the longest side in the right angled triangle. Let's move to the next point, which is a very important remark. In the previous example, I got that sine B equals 4 over 5 and also cosine C is 4 over 5. Moreover, I got that sine C equals 3 over 5 and also cosine B is 3 over 5. By noticing that I had a right angle triangle like this, B, C and A is a right angle. As we said before that the sum of the interior angles of any triangle equal 180 degrees. So when I say that measure of angle A equals 90 degree because it's the right angle, so I can find easily that angle B plus angle C, their sum will be 90 degree. If I have two angles, their sum is 90 degree, then I can say that they are complementary angles. So we have a very important note here. Take care of this point, please. If I have two angles, their sum equals 90 degree, then you will find that sine the first angle equals cosine the second angle, and vice versa. Cosine the first angle equals sine the second angle. This means that the two angles are complementary or their sum equals 90 degree. Also, we find that sine angle B was 4 over 3. By noticing that sine B is 4 over 5, cosine B is 3 over 5, then I got the tan of the angle B, which is 4 over 3. Here we can say that the tan for any angle, you can find it by another rule, which is sine over cosine. So I got two rules for the tan. To find tan angle A, it will be opposite over adjacent, or it will be sine A over cosine A. So repeat with me these two important notes. The first note is that if we have two complementary angles, then the sine of the first angle equals cosine the second angle, and cosine the first equals sine the second. And to find tan any angle, it's equal to its sine over its cosine. Let's solve some questions to make sure that we got it. If sine 30 equal cosine theta, what is the measure of theta? I noticed that you told me that if I have two angles, their sum is 90 degree, then the sine of the first will be equals cosine the second. Then theta equals 90 minus 30, which is equal 60. Second question, he is telling me that x and y are the measures of two complementary angles. Cosine x equals 4 over 5. If they are two complementary angles, then sine y equal cosine x equals 4 over 5. Look about question 3, which is very important. In triangle ABC, measure of angle A equals 60 degree. Sine B equal cosine B. Sine B equal cosine B, it means that B plus B equal 90 degree. the sine equals to the cosine if these two angles are complementary angles. What is the meaning of complementary angles? Complementary angles, their sum equals 90 degrees. So b plus b equals 90, then I got that 2b equal 90 degree, then b equals 45 degree. And from here, from this point, I'm telling you that take care while you are solving. The only angle which has the same value for sine and cosine is 45. So measure of angle A equals 60, measure of angle B is 45. What about measure of angle C? It will be 180 minus 60 plus 45, it will be like 75. Look at the next question. In triangle ABC is a right angle triangle at B. I will draw a simple triangle like this, ABC. B is a right angle. This means that sine A equal cosine C and cosine A equal sine C. So you can put instead of cosine C sine A, because A and C are two complementary angles, and you taught me that two complementary angles, then the sine of the first equal cosine the second. Then it will be sine A plus 2 sine A, which is 3 sine A. Okay, let's move to the next part. Another question for the very important one. These two ideas are very important for me, so let's solve again on them. Measure of angle A equals 75. Sine B equals cosine A. Sine B equals cosine A. Again, I'm saying sine B equal cosine A. Then I got it. A plus B equals 90 degrees. They are two complementary angles. So you are telling me that A is 75. What is the complementary angle of 75? I think B will be 15 degrees. So I got it. In the next question, ABC is a right angle triangle, angle B equals 90 degrees. So I will write it like this. When you read this question, you should recognize that if angle B is a right angle, then A and C are two complementary angles. Then cosine A equals to sine C and sine A equal cosine C. So I can replace sine C by putting instead of it cosine A. So it will be cosine A plus cosine A, which is 2 cosine A. Okay, let's solve a question which is higher a little bit. XYZ is a right angle triangle at Z. First of all, you should draw a simple triangle like this, the right angle triangle at Z. So I will put X and Y, whatever you want. XZ equals 7 centimeters, XY equals 25 centimeters. Find the value of, before you start, as we said before, you should find the missing side. What is the missing sides? It's YZ. May I ask you a question? Is YZ a hypotenuse? No, it's not opposite to the right angle. So to find YZ, I will make a square root, the greater number raised to the power of 2 minus or subtracting from it the smaller side raised to the power of 2 to get it 24 centimeters. Let's move to the next point and to find what he is asking me for. He is asking me about 10x multiplied by 10y. 10x, I'm standing at x, opposite over adjacent, which is 24 over 7, and 10y, opposite over adjacent, which is 7 over 24. As you see, they are multiplicative inverse or reciprocals, so their product is equals to 1. The second point is sine squared x plus sine squared y. It means that I will find sine x, then I will making it to the power of 2 or squaring it. Opposite over hypotenuse, so it will be 24 over 25 all to the power of 2 plus sine squared y. It will be opposite. The opposite to the angle y is xz, so it will be 7 over 25 raised to the power of 2. It will be 625 over 625, which is equals to 1, and we got it. Let's solve another question. ABCD is an isosceles trapezoid. The word trapezoid means a trapezium in which AD is parallel to BC and AD equals to 4, AB equals to 5, BC equals to 12. I will draw the figure of isosceles trapezium. As you know, the isosceles trapezium has two equal sides. Those are two parallel sides. AD is parallel to BC. AD equals 4, AB equals 5. Then I got it AB equal DC equals 5 centimeters. Okay, and BC equals 12. How to find sine or cosine or tan without getting a right angle triangle and find all its missing side? So how can you find the right angle triangle here? I will draw a construction. I will drop a perpendicular line here, which is called AX, and a perpendicular line also here, which is called DY. Right, for him, draw AX perpendicular on BC, draw DY perpendicular on BC. Why did you draw AX and DY? I did it to find that AXB triangle, it will be congruent to the triangle DYC. Moreover, I will got two right angle triangles, and ADYX will be a rectangle. How could you know that it's a rectangle? I have two parallel sides and two right angles. Only one right angle will make it a rectangle, by the way. So in the rectangle, we used to know that each two opposite sides are parallel and equal. Then XY will be equals to AD equal 4 centimeters. And you said to me that AXB is congruent to DYC, then BX equals YC equal 12 minus 4 divided by 2, so it will be 4 here and 4 here. The last point is to get AX, which is equal DY. This is in the right angle triangle ABX, which is not a hypotenuse, so it will be square root 5 power 2 minus 4 power 2, it will be 3. Now I got all my sides. Let's start again after putting your sides. We have again an isosceles trapezium like this. ADBC, this is 5 centimeters, it's 4, and here I got AX, which is equal 4, XY, which is equal 4, YC, which is equal to 4 centimeters, and those two sides are 3 centimeters. Now let's find 5 tan B multiply cosine C. I will find the tan B, I will find cosine C, I will find sine C, I will find the cosine B. Let's do it now. Tan B means opposite over adjacent, so it will be 3 over 4. Cosine C, it will be adjacent over hypotenuse, so it will be 4 over 5. Sine C, opposite over hypotenuse, 3 over 5, and cosine B will be adjacent over hypotenuse, so it will be 4 over 5. Substitute here 5 multiplied by tan B, which is 3 over 4, multiplied by cosine C, 4 over 5, over sine squared C, 3 over 5 raised to the power of 2, cosine square B, which is 4 over 5 raised to the power of 2, and I will get the answer, which is equal to 3, and which is the required to prove. Now we have finished the first lesson in the geometry of the first term. Before we end this video, I hope you got it, and I'm asking you, please solve these problems again and solve extra problems. To see you in the next video. Good luck for all.